Hello, my name is Dan Montone, Marketing Director for the Haydon Kerk Motion Solutions Business Unit of Amatec Precision Motion Control. Today I would like to introduce you to the technology behind our hybrid stepper motor linear actuator products. Haydon Kerk hybrid linear actuators are available in frame sizes ranging from our smallest, which is approximately 0.8 inches square or 20 millimeters, to our largest, which is approximately 3.4 inches square or 86 millimeters. Double stack hybrid linear actuators are also available in certain frame sizes. All our actuators are available in 3 different mechanical configurations: captive, non-captive, and external linear. The captive configuration is a self-contained unit with built-in anti-rotation. However, it's limited to shorter stroke lengths. The non-captive and external configurations are perfect for longer stroke lengths, but they need to be mounted using a method that will ensure anti-rotation. These devices are capable of a linear output force ranging from approximately 10 pounds to 500 pounds, or 44 newtons to 2,224 newtons. The output speed range of a particular actuator is dependent on several variables, including the type of stepper motor drive, as well as the voltage rating of the motor coil and the maximum output voltage capability of the drive. As seen in the chart, maximum output will be obtained using a chopper drive with about an 8:1 drive-to-actuator voltage rating. Our captive and non-captive linear actuators use an internal nut to convert rotary to linear motion directly within the motor itself, making these devices quite unique when compared with conventional rotary stepper motors. In this cutaway, you'll see the magnetic rotor and bearings are mounted on the internal nut assembly. This assembly is made from a combination of polymer and brass. This is a larger version of the same nut design found in the cutaway. Let's look at why it's important to use 2 different materials for the internal nut assembly. As illustrated in this chart, the coefficient of friction is almost 2 times more when using a bronze lead screw nut compared with a plastic nut. Plastic is the clear choice for minimizing system friction. On the other hand, as good as plastic is for lead screw nut threads, it's not a stable enough material for the bearing journals of a hybrid stepper motor. In order to achieve the high performance characteristics of a stepper, the design must maintain very tight tolerances for the stator to rotor air gap. This tight design requirement demands thermally stable bearing journals. This chart illustrates the thermal expansion of a 1-inch sample of both plastic and bronze. At 130 degrees C, the bronze material remains dimensionally stable, while the plastic material changes significantly. The thermal expansion curve for the plastic material also slopes up much more than the bronze material over a wide temperature range. By injection molding plastic threads with a brass sleeve with precision machine bearing journals, both requirements of a low-friction screw nut interface and bearing journal temperature stability are achieved. The result is an actuator with quiet operation and high efficiency compared with one using the traditional bronze lead screw nut. You may be wondering how a plastic nut compares with a bronze nut relative to overall life of the actuator. This semi-log chart illustrates life test data for both a plastic nut and a bronze nut. Using a plastic nut improves motor life by 10 to 100 times over the traditional bronze nut configuration. When properly applied, Haydon Kerk linear actuators can operate for millions of cycles. That's it for now. Thank you for watching. For more information, visit us at www.haydonkerk.com.